Here is a test question on Unit 1 Calculus. We need to find a point on which the slope of the tangent is same as the slope of the secant on the curve. I am Anil Kumar. Welcome to my YouTube channel and the website Global Math Institute. In case you want to learn directly from me, feel free to send an email on globalmathinstitute@gmail.com. Our students are right there on the top, getting admissions to the best universities with scholarship. Here is introductory Unit 1 Calculus test question. A secant line cuts f of x equals to square root x at points where x equals to 1 and x equals to 9. Determine the point on f at which the tangent line is parallel to the secant. So derivatives give you the slope. We need to find the slope of the secant line and then a point on the curve when the slope matches. Let's try to visualize the situation. So what we have is a square root x function. So let me just sketch it here. So this is going to be a rough sketch. Starts from 0, all values are positive, correct, something like this. So the function is square root of x. We are given 2 points on this curve, which are x equals to 1 and x equals to 9. And we know that when we touch them through, or when a line goes through them, it forms a secant line, right? So by definition, secant is a straight line between any 2 points on the curve. Let's call these points as A and B. Coordinates of point A, we know the x value here is 1, so it is going to be 1 square root 1, which is 1, so we can say 1, 1. At B, the value of x is 9, and square root of 9, this is not to the scale for sure, is going to be 3. So this point here is 9, 3. So once you identify the 2 points, it is very easy to find slope of the secant line, right? So let's say, so what we have done is, we are given a function f of x, which is square root of x. We found the value f of 1, which is square root of 1, which is 1, f of 9, which is square root of 9, which is 3. So that gives us 2 points as shown on the graph, point A, which is 1, 1, and point B, which is 9, 3. So that part is clear. Now let us find the slope of the secant AB. So let me write this as MAB, slope from A to B, using simple formula y2 minus y1 over x2 minus x1, which means 3 minus 1 over 9 minus 1, and that is minus 3 minus 1 is 2, and this is 8, 1 over 4 is the gradient or the slope of the secant, correct? Now we need to find a point on this function where the tangent is parallel, right? So basically what we do is that we can draw a line which is parallel to AB, something like this. You see that? And then we need to find this particular point where it is parallel to the secant line. So let's call this point as P, which we need to find. But what we know really is slope at P, right? Slope or gradient at P is So we know the slope or gradient at P is actually 1 by 4, or we can technically write as derivative at this point P, right, is equal to 1 by 4. So let's call this x coordinate as P. Lowercase p I'm writing. So capital P is my point and f of P will be its y value. Makes sense, right? Correct. So let's take it on the next page. Now the idea is to, so we have come down to this question as we know that the derivative at point P is 1 by 4, correct? Where the function given to us is square root of x. Derivative of the function is x to the power of half, means half x to the power of minus half. So I could write this as 1 over 2 square root of x. Clear? So substituting the, this is prime, right? So substituting the slope at P, which is, we know, 1 by 4, we can actually find the coordinates of point P, right? 1 over 2 square root of P. Makes sense? Because the x value is P there, right? So that really means 2 square root P equals to 4, or square root P equals to 4 divided by 2, or 2. And when you square, you get P equals to 2 square, which is 4. So we get the coordinate point x value for P. Now we can find the y value also. So f of 4 will be square root of 4, correct? Which is 2. And therefore, we know that the coordinates of point P are 4, 2. Make sense? So we have solved this question and found a point on F where the tangent line is parallel to the secant line. Does make sense? So that becomes the basic concept with which we are going to solve many questions where tangents are involved, and for different given conditions we'll find their equations. I hope you have understood this basic concept. Feel free to write your comments and share your views. If you like and subscribe to my videos, that'd be great. Thanks for your time and all the best.